Good morning, students. This is A.V. Satyanarayana, working as a assistant professor in physics in MBR College of Engineering and Technology, Paratala. Now we will discuss about Davisson and Germer experiment. The first experimental evidence of matter wave was given by two American physicists. They are named as Davisson and Germer in 1927. Matter wave, a moving particle associated with wave, is called as matter wave. The matter wave experimental evidence is given by two scientists. They are named as Davisson and Germer in 1927. They also succeeded in measuring the de Broglie wavelength associated with slow electrons. So they also succeeded in measuring the de Broglie wavelength lambda associated with slow electrons. So experimental arrangement. The operators consists of an electron gun G, where the electrons are produced and obtained in a fine pencil of electron beam of known velocity. The operator consists of electron gun G, where the electrons are produced and obtained in a fine pencil of electron beam of known velocity. The electron gun consists of tungsten filament F heated to dull red, so the electrons are emitted due to the thermionic emission. Now the electrons are accelerated in the electric field with known potential difference. After this, electrons are passing through the slits and finally obtain a fine beam of electrons. The beam of electrons falls on a large single crystal of nickel known as target T. The electrons acting as a waves are diffracted in different directions. The angular distribution is measured by an electron detector made with a Faraday cylinder. It is moving on a circular graduated scale S. The cylinder is connected with a galvanometer G. The Faraday cylinder consists of two walls which are insulated from each other. A retarding potential is between them, so that only fast moving electrons are enter inside it. The secondary electrons produced by the collisions of atoms from the nickel target are reflected by the Faraday cylinder. So the galvanometer shows the deflection by the electrons coming from the gun entered in a Faraday cylinder. So the electrons are incident on the nickel target by the 90 degrees. They are diffracted with the angle of diffraction theta is equal to 50 degrees and the voltage 54 volts. So under these conditions, the surface rows of atoms act like the ruling of diffraction grating, producing the first order spectrum of 54 volts of electrons at theta is equal to 50 degrees. So using the Bragg formula, 2d sin theta is equal to n lambda. Here d is equal to interatomic distance is equal to 0.09 into 10 to the power of minus 10 meters. Theta is equal to angle between incident beam and interatomic plane, that is equal to 90 minus 25 is equal to 65 degrees. Lambda is equal to wavelength of the electron beam. These all values are substituted in the formula of 2d sin theta is equal to n lambda. Finally, we can getting lambda is equal to 1.65 into 10 to the power of minus 10 meters, that is equal to 1.65 angstroms. According to de Broglie electron wave, lambda is equal to 12.26 by root 54, that is equal to 1.67 angstroms. As the two values are good agreement, hence confirming de Broglie concept of matter waves. Hence, the two values are good agreement. Hence, confirms the de Broglie concept of the matter waves. This is the graph between number of scattered electrons and scattered directions. The scattering curve shows the peak. The scattering curve shows the peak for a particular direction. Theta is equal to 50 degrees. So this is the parallel planes. The distance between two parallel planes is called as interatomic distance. This is the angle between the incident. This is the angle between the incident beam and interatomic plane. So here in the Bragg's formula, 2D sin theta is equal to n lambda, d is equal to interatomic distance, d is equal to interatomic distance, theta is equal to angle between incident beam and interatomic plane. Theta is equal to angle between incident beam and interatomic plane. So we substituted 2 into d is equal to 0.09 into 10 to the power minus 10 meters, and theta is equal to 90 minus 25. So 90 minus 25 gives us, see here is also gives 65 degrees. 65 degrees. Finally, we can getting lambda is equal to 1.65 into 10 to the power minus 10 meters. 1.65 into 10 to the power minus 10 meters. 10 to the power minus 10 meters gives us 1 angstrom. So lambda is equal to 1.65 angstroms. But according to de Broglie electron wave theory, lambda is equal to 12.26 by root V. Here V is equal to 54 volts because the accelerating electrons accelerated with the voltage 54 volts. So to substitute the value of V, we can getting lambda is equal to 1.67 angstrom units. As these two values, lambda is equal to 1.65 angstroms according to the Bragg's equation, lambda is equal to 1.67 angstroms according to the de Broglie electron wave. These two values are in good agreement, hence confirm de Broglie concept of matter waves. This is the experimental evidence of the Davisson and Germer experiment. Once again, briefly we can discuss about the Davisson and Germer experiment. The experimental apparatus consists of electron gun, which is produced the electron obtained by a fine ray of beam of electrons, and the gun consists of the filament. It is heated to dull red. So the electrons are produced by the thermionic emission. The electrons are accelerated in electric field. The electrons are passing through the slits and obtained a fine beam of electrons. These electrons are falls on a nickel target. These are diffracted with different directions with the angle of diffraction theta is equal to 50 degrees. These are graduated with Faraday cylinder. The cylinder moves on the circular disc S. The cylinder having two walls. The two walls are insulated with each other. The retarding potential is between them. So only fast moving electrons are allowed inside it. The secondary electrons produced by the collision of atoms from the nickel are reflected by the cylinder. So the galvanometer shows the deflection. Only the electrons from gun entered in the cylinder. So the scattering curve shows a peak for a particular direction of theta. Finally, the values are substituted in the Bragg's formula. 2D sin theta is equal to n lambda, d is equal to interatomic distance, theta is equal to angle between incident beam and interatomic plane. Finally, we can getting lambda is equal to 1.65 angstroms. But the electrons are accelerated by the 54 volts with the angle of direction 50 degrees. So according to de Broglie electron wave, lambda is equal to 12.26 by root 54, that is equal to 1.67 angstrom units. These two lambdas giving a good agreement, hence confirms the de Broglie concept of matter waves. This is the graph between scatter of electrons, number of electrons, and the scattering of direction. This is the number of parallel planes and the incident beam, the angle between the incident beam and parallel plane 65 degrees. So this is the experimental evidence of Davisson and Germer experiment. Now up to we discussed about Davisson and Germer experiment. Now we discussed about G.P. Thomson experiment. G.P. Thomson performed experiment with electrons accelerated from 10,000 to 50,000 volts. In his experiments, Thomson observed diffraction pattern exactly similar to X-rays. In his experiments, Thomson observed diffraction pattern exactly similar to the X-rays pattern. Moreover, he was able to determine the wavelength of associated with the electrons. Wavelength associated with the electrons. So the high energy of electron beam produced by the cathode C. The high energy of electron beam produced by the cathode C. The beam is excited with potentials up to 50,000 volts. The beam is excited with 50,000 volts of beam. A fine pencil of this beam is obtained by passing through the slit or diaphragm S. A fine pencil beam of ray is passing through the slit or diaphragm. This beam is incident on the gold foil. It is thin film. The thickness of the thin film is 10 to the power of -6 centimeters. The thin film is made with either gold or aluminum. The photograph of the beam from the foil is recorded on the photographic plate. Whole of the apparatus is kept in a vacuum, so the electrons may not lose their energy in collision with the molecules of the gas. Whole of the apparatus kept in a vacuum in the glass tube, so the electrons does not lose their energy with collision of molecules in the gas, because the vacuum didn't have any gas, so there is no gas, there is no molecules, so the electrons does not lose their energy. After developing the plate, a symmetrical pattern consisting of concentric rings about a central spot is obtained. This pattern is similar to produced by X-rays So after developing the photographic plate, the pattern consisting of concentric rings about central spot is obtained. This pattern is similar as produced by the X-rays. To show that this pattern is due to electrons or due to X-rays. So this pattern is obtained by only electrons, because of the cathode rays in the discharge tube are deflected by the magnetic field. The cathode rays in the discharge tube is deflected by the magnetic field. So the pattern can be obtained by only electrons. Only electrons are deflected by the magnetic field. So the pattern is produced by the only electrons. The observed rings can only be interpreted by the considering the diffraction pattern of the incoming beam is due to the diffraction of the electrons by the foil. The observed rings obtained by the diffraction pattern by the diffraction of electrons by the foil. As the diffraction pattern only produced by the waves and not by the particles, so Thomson concluded that electrons behaves like the waves. Thus, Thomson experiments clearly demonstrated the existence of matter waves. He also calculated the associated with wavelength and observed that it depends only on the accelerating voltage and it is independent of the material of the target. Thomson experiments clearly demonstrated about the matter waves. He also calculated the associated wavelengths and observed that it depends on only the accelerating voltage and is independent of the material of the target. So once again, we discussed about the G.P. Thomson experiment. G.P. Thomson performed the experiments with electrons accelerated up to 10,000 to 50,000 volts. The high energy of electron beam produced by the cathode rays up to 50,000 volts. This beam is passing through the slit or diaphragm, and this diaphragm is incident on the gold foil. It is thin film. Its thickness T is equal to 10 to the power of -6 centimeters. The foil is made up of either gold or aluminum. The photograph is recorded on the photographic plate. After the developing of the photograph, similar concentric rings about central spot is obtained. This pattern is similar to produced by the X-rays. To show that this pattern is obtained by the either X-rays or electrons. So perfectly we can conclude that the pattern can be obtained by the electrons, because the cathode rays are the cathode rays in the discharge tube are deflected with a magnetic field. So the pattern is obtained by the only by the electrons. The observed rings can only be interpreted by the diffraction pattern of diffracted electrons by the foil. So the observed rings only interpreted by the diffraction of electrons by the foil. The diffraction pattern can be only produced by the waves and not by the particles. So Thomson concluded that electrons behaves like as a waves. The diffraction pattern can only be produced by the waves and not by the particles. So the Thomson concluded that electrons behave like as a waves. Thus Thomson experiments clearly demonstrated about matter waves. He also calculated the wavelength, and the wavelength is depend upon only the accelerating voltage but not the material of the target. This is the explanation about G.P. Thomson experiment and Davisson and Germer experiment. Thank you all.